Alright, so here's an example problem where I'm asked to find the vector projection of V onto B, where I'm given the component form of B, and I'm just given the magnitude of vector V, but I'm given the angle in between them as well. So if I start working through this, what I'm really looking for is I'm looking for that piece X. The length of that is the scalar projection. The vector in that direction is my vector projection. So we're going to use just right triangle trigonometry. There's a formula in the book that you're welcome to use if you want. But this is what we're asked to find, and so it's easier just to think of it in terms of triangles as we go through it. So what I'm looking for, I know that's 100. It's given as that magnitude. And if I think about my cosine value of 145, that's going to be a negative value. So x is going to be cosine 100 cosine 145, which gives me a negative value as I go through this. So that becomes the scalar projection, but now I need to scale vector b by that. So I need to first off find a unit vector that's in the direction of b. So a unit vector is a length of 1. To determine that, what I need to do is to figure out the magnitude of b. So I calculate that value, and then every component for b is going to get divided by that, which will give me a length of 1. So if the magnitude was 10, if I take everything divided by 10, would be a unit vector of 1, because 10 over 10 is 1. So I start plugging through the algebra of that. I'm going to take that whole thing divided by the magnitude of b, and then it gets multiplied by vector b. So it's a scalar of vector b. What that looks like as we work through it, cosine 145 times 100 is negative 81.9, and then to figure out the magnitude of b, I use my Pythagorean theorem for 3 dimensions. So 50 squared, negative 60 squared, 40 squared, and that number becomes negative 81 over 87.7, and all of that gets multiplied by the components of vector b, which is given in the problem. So we have that scalar, we multiply it through, and that works out whatever that number is. So something a little bit less than 1 negative is going to multiply 50, negative 60, and 40, and that will be our vector projection of V onto B.